The situation was somewhat like this way, right? There was this point A and B. This is our resistors. We were working towards A to B, right? Here the suppose potential is VA, here potential is VB. So we can write VA minus IR is equal to VB. Why? Because we are walking along the direction of electric current. So the potential across AB point is IR, right?
Yes, sir.
So similarly, in this same situation, what if you are walking opposite to the electric current? Let's say this is electric current and you are walking in this direction. Now what will happen? See, let's see. We are walking from VB, right? This point B. So potential at B is VB. Here it is VA. Now we are walking opposite to the direction of electric current. So here the resistance is R. So here potential drop will be IR, right? But since we are walking opposite to the electric current, we are going to take it as positive. Plus IR is equal to VA. So can we write it this way? VB minus VA is equal to minus IR. Yes, of course.
Yes, sir.
Now if you
But you
multiply,
like VA minus VB is equal to IR also, right?
so if you multiply this expression with negative sign, it will simply become VA minus VB is equal to IR. That is our first expression, right? So we are right in the both the scenario. Okay, write it down. Why did we get this negative sign here? Because current is flowing from VA to VB, right? And remember I told you that current flows from higher potential to lower one. Here higher potential is VA. Okay, that's why current is flowing from VA to VB. But we have taken the opposite direction. That's why we are getting this negative. Otherwise, we would get positive sign, right? So this was the sign convention. Now let's talk about another sign convention. When you encounter a battery in the path, okay, then what we are going to do? Let's discuss it. So this is the battery. Same situation A to B. Here we are going to assume, okay, let's say current is flowing from in this way, okay, B to A. Or should we take opposite? Oh, let's take opposite direction of current. Let's say current is flowing from A to B, okay? But since here it is the positive terminal, that's why we are going to take its direction as in this direction, okay? Now, what to write, okay? How do we write potential difference between these 2 points? Now this is the battery and it must have some internal resistance R, right? Yes or no?
Yes, sir.
So we can write it as like this way. So current is in this direction. This is E. So first of all, we are going to walk from VB to VA, right? In this direction. So we are walking along the direction of electric current. So here we will write VB. So since we are going in the direction of electric current, we are going to take this potential as negative, right? Minus IR. Now remember, in the battery, if you encounter any battery along the path, please take the second sign, okay, not the first one. Here the first sign is what? Negative. This is negative terminal, this is positive terminal, right? So always write second sign. Here it is positive, so we are going to write plus E equal to this V. So we can write VB minus VA is equal to IR minus, can we write it this way?
Yes, sir.
Or VA minus VB should be E minus IR. Right? We just multiplied it with the negative sign. Understood? Do you want me to write this in words? Let
No,
me
sir.
write it. Whenever you encounter a battery in the path, always consider second sign. Always consider second. So in this path, we need to write VB minus VA, right? So we are going to walk
Yes.
along the direction of electric current. So it would be VB minus this IR because we are walking along the direction of electric
Yes.
current. Now we are encountering the second sign which is plus E, okay? So we are going to write
Yes.
plus E again minus IR is equal to, this is VA,
Sir, could you explain why minus IR, capital IR would come?
because here is
Capital
the,
R for capital R.
here it is capital R resistance.
Okay.
So we can write VB minus VA is equal to I into small r plus I into capital R minus E, or we can write it as I in the bracket R plus capital R minus, if you multiply this expression with negative sign, we can write it as VB minus VA. VA minus VB
Equal
is
to
equal to E minus I into small
IR
r plus capital R.
R.
Understood?
Yes.
Now Kirchhoff's first rule, which is junction rule, which is junction rule. This rule is very silly, but it is having a much importance in this chapter, okay? What it says is that at any junction, at any junction, the sum of the currents entering the junction is equal to currents leaving the junction. That's it. For example, currents meet, junction means where the different currents meets, okay? Let's say in this case these are the incoming currents, okay? I1, I2, I3. And let's say these are the leaving currents which are leaving, okay? I4, I5, I6. So what is this statement? That the entering and leaving currents, the sum of entering and leaving currents is what? Equal. That means I1 plus I2 plus I3, which are the entering currents, will be equal to the leaving currents, which is I4 plus I5 plus I6, right? This portion, we can also write it as I1 plus I2 plus I3. If you take these terms in this side, it will become negative, is equal to 0. This is the first rule. Now second rule. What is the second rule? It is also known as loop rule. It says that algebraic sum of changes in potential around any closed loop involving resistors and cells in loop is 0. Okay, so what does this mean? Let me explain. So let's take one circuit. Okay, this is resistor, only resistor. Let's take only one or two resistor. There are two resistors. Let's say it is R1, let's say it is R2. Okay, and let's take one battery also. Here is the battery. Okay, so current would be what? This is the positive terminal of the battery, so current would be in this direction, right? From positive to negative. What it is saying is that at any point, okay, so let's name these points A, B, C, D. It says that if you start from this D point and at D point, the sum of all the potential should be 0. Okay, let's try this. Let's say its potential is Vd. Okay, so we are walking from Vd. Okay, we are in the direction of electric current, right? Because current is in this direction, right? So Vd, let's say it is E. So it would be plus E. Why? Because we are, this is the second sign, right? Let's say at this point, its potential is Vc. And across this resistor, it would be minus IR1 because we are going in the direction of electric current. Let's say at this point it is Vb, so plus Vb. Let's say at this point it is Va, so plus Va. Okay, and there is this resistor. Okay, so it will be minus IR2 is equal to, this is our final point, right? And it would be what? Vd. Yes or no?
Yes, sir.
So, but in this case, both the Vd are positive, right? So if you take this Vd to left hand side, it will become
Okay,
0.
cancel.
And if they become 0, our expression would be E plus Vc minus
plus
IR1 plus Vb plus Va minus IR2 is equal to 0.
is equal.
Okay. So the statement
Yes,
is
sir.
algebraic sum of changes in potential around any closed loop. Here it is our loop, right? This is our loop. Any closed loop involving resistors and cell in loop is 0. If you start at any point and end at this point, then the sum of all the potential will be 0.
0.
Understood?
Yes, sir.
Okay. Let's say there is this question. Find the current in given circuit. So the circuit is somewhat like this way. And by using Kirchhoff's law, we are going to find the, this is 5-volt battery, resistance is 4, here it is 5. Okay, and we got to find the electric current using Kirchhoff's law. Okay, otherwise we can solve it by using Ohm's law, right? First
Yes.
find out the equivalent resistance and use the V is equal to IR, then we get the answer. But here we want to use the Kirchhoff's law. So we are going to start it from this point A, okay, and we'll end at this point A also. So start from here. So Va minus 4 into I, right?
Yes, sir.
Minus 5 into I. Here it is positive, here it is negative. So we are here. So it would be plus 5 is equal to Va. This Va will get cancelled out. So finally, minus 4i plus 5i is what? Minus 9i plus 5 is equal to 0. That means 9i is equal to 5. That means I is equal to 5 by 9. That's our answer.
Yes, sir.
Easy?
Yes, sir.
That's it.